The last of the 3 giant asteroids to pass Earth will be tomorrow. New NASA research shows that giant asteroids have battered the early Earth in the past, creating great catastrophes. They show a surface plummeted by large impacts, resulting in the extrusion of deep-seated magma onto the surface. Well, we've seen magma coming onto the surface lately in the hotspot of the Kilauea volcano in Hawaii. At the same time, in the past, distal portions of the surface could have retained liquid water. Well, new research shows that more than 4 billion years ago, the surface of the Earth was heavily reprocessed or melted or mixed and buried as a result of giant asteroid impacts. A new terrestrial bombardment model, calibrated using existing lunar and terrestrial data, sheds light on the role asteroid collisions played in the evolution of the uppermost layers of early Earth during the geological eon called the Hadean, that was approximately 4 to 4.5 billion years ago. An international team of researchers from academic and government institutions, including NASA's Solar System Exploration Research Virtual Institute, SSERVI for short, at NASA's Ames Research Center in Moffett Field, California, published their findings in a paper titled Widespread Mixing and Burial of Earth's Hadean Crust by Asteroid Impacts, end quote. This was in the issue of Nature magazine, July 31st, 2014. Yvonne Pendleton of SSERVI, the director of Ames, said a large asteroid impact could have buried a substantial amount of Earth's crust with impact-generated melt. This new model helps explain how repeated asteroid impacts may have buried Earth's earliest and oldest rocks. The terrestrial planet formation models indicate that Earth went through a sequence of major growth phases, initially accretion of planetesimals, planetary embryos, over many tens of millions of years, and then a giant impact by a large protoplanet that led to the formation of our moon, followed by the late bombardment that when giant asteroids several tens to hundreds of miles in size periodically hit ancient Earth, dwarfing the one that killed the dinosaurs, estimated to have been 6 miles in size, and that was 65 million years ago. Researchers estimate accretion during the late bombardment contributed less than 1% of Earth's present-day mass, but the giant asteroid impact still had a profound effect on the geological evolution of early Earth. Prior to 4 billion years ago, Earth was resurfaced over and over by voluminous impact-generated melt. So there was the impact and then the melt. The magma came out and flooded the Earth. Okay, so that was the voluminous impact-generated melt. Furthermore, large collisions as late as about 4 billion years ago may have repeatedly boiled away existing oceans into steamy atmospheres. Despite the heavy bombardment, the findings are compatible with the claim of liquid water on Earth's surface as early as about 4.3 billion years ago based on geochemical data. The new research reveals that asteroidal collisions not only severely altered the geology of the Hadean eon on Earth, but likely also played a major role in the subsequent evolution of life on Earth as well. Quote, prior to approximately 4 billion years ago, no large region of Earth's surface could have survived untouched by the impacts of their effects, end quote, said Simone Marchi, SSERVI senior researcher at the Southwest Research Institute in Boulder, Colorado, and the paper's lead author. Quote, the new picture of the Hadean Earth emerging from this work has important implications for its habitability, end quote. Large impacts had particularly severe effects on existing ecosystems, as we can imagine. Extinction level events, if there was life on Earth, you could imagine. researchers found that, on average, Hadean Earth more than 4 billion years ago could have been hit by 1 to 4 impactors that were more than 600 miles wide and capable of global sterilization, and by 3 to 7 impactors more than 300 miles wide and capable of global ocean vaporization. Bad news, you could imagine. Quote, during that time, the lag between major collisions was long enough to allow intervals of more clement conditions, at least on a local scale, said Marchi, adding, any life emerging during the Hadean eon likely need to be resistant to high temperatures and could have survived such a violent period on Earth's history by thriving in niches deep underground or in the ocean's crust. End quote. The research was an international effort led by Marchi and Williams Botkip from the Southern Research Institute in Boulder, Linda Elkins-Tanton from Carnegie Institute for Science in Washington, Michael Beerhaus and Kai Wunemann from the Museum für Naturkunde in Berlin, Germany, Alessandro Mordibelli from Observatoire de la Côte d'Azur in Nice, France, and David Kring from the University Space Research Association and Lunar Planetary Institute in Houston, Texas. The research was supported by SURVEY and Virtual Institute, that international partnerships bring science and exploration researchers together in a collaborative virtual setting. As SURVEY is funded by Science Mission Directorate and Human Exploration and Operations Mission Directorate at NASA headquarters in Washington. I'll leave a link below for you for this. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.